Hi, okay, in this tutorial we're going to be looking at first steps of running Caesar in reach mode. So reach mode differs from catchment mode in that the model operates at a reach, so it requires inputs to point rather than the inputs of rainfall. So straight away we can see in the folder here, quick start reach mode, we've got the Caesar executable, we have the DM file, a section of River Jesus, an input file for the discharge that's being input at points, and the XML file that's used as a config. So we double click on the exe file and upload Caesar. Okay, so upload 2 there. Then we can load in all the parameters by clicking open and go to that XML file that we saw, reach 1, double click on that, and it populates all the boxes within here. Now, difference here between reach and catchment mode is we don't have a rainfall file, so we just have a DM file. We've not got a bedrock data file here as well. The important difference is if we go to the hydrology tab, we can now see that we have a set of inputs, and these inputs are all at certain points. We have the X and the Y coordinates of the inputs. What I've done is I'm taking the inputs from one file, input2.txt, I'm inputting it at 3 points, all next to each other, so we get a nice equal spread of water coming in. And we also divide the inputs by 3, so we have one file that contains all the data of water. And this is the time step input data in minutes. Okay, so here it's very long. 1440 minutes is a day, so what's that? 10,000 days for each line on input2.txt. I've just done that really simply just to make sure it operates. And if we look at what's in input2.txt, it's in the same format as the output that comes from Caesar, you might have seen before. So we have a timestamp, the amount of water, then 2 redundant columns, and then the total amount of sediment coming in, then the sediment in each one of the grain sizes. So you can input sediment at these points as well. Anyway, that's easy. We start the model by click load data. We cut this checkbox. It's actually warning us we might have a too high number of scans. I'm not going to worry about that for now. Click OK, press start, and all starts to run. We can see we're inputting 10 cubic meters a second of water, and we get it roughly that coming out. If we click on update graphics, we can see here we have our river. We can post on the DM in the background by clicking there. We can zoom out a couple of sections so we can see the whole thing. Come out one more. Okay, there we have our DM. So it's inputting water at these 3 points, which is then being routed along this section, along here and out here. The numbers in the tab here, that's the number of iterations, that's the time that's elapsed since it started, that's the water discharge, that's the amount of sediment that's coming out at each iteration. Now if we click and look at the amount of erosion deposition, okay, we can see that clearly we're starting to have a pattern. Erosion starting here, bit of deposition here, nothing happening there, erosion in red, sorry, and green in deposition there. Okay, so the model's working fine. It's eroding and depositing as we might actually expect it to do, I guess. Okay, and we can look at other things. We can look at grain size that's being developed on the bed of the river. We can look at all sorts of other things if we want to. Okay, so what we're going to do now is we're going to try and simulate a flood. So to do that, I'm going to quit Caesar, and I'm going to edit the input file that we had before. I'm going to edit it in that. I'm simply going to up the discharge. Instead of 10 meters cubic second, I'm going to make it 200 meters cubic second. Save the file, close, load up Caesar again, the run, load in the data, click load, click OK, click start, and away we go again. And what we'll probably find here is it'll take a lot longer to run, and that's because we're actually routing a lot more water straight away. If I just a couple of sections, you can see we're getting overbank flows here. Okay, so the water's coming in from the left and being routed over the top of the floodplain there. Okay, and these patterns are changing slightly. Okay. Now, what we might expect to see now is some slightly different patterns of erosion and deposition occurring. Okay. And we'll also notice that the time step has dropped right down. It's running slower, and the time step has fallen. That's because Caesar has this variable time step which adjusts the time step according to the amount of erosion and deposition that's occurring within the catchment, and that's set by a value. In this case, it's 5 centimetres, 0.05, 0.05 per metre is the maximum amount of erosion deposition that can happen anywhere within the catchment. Okay, and that's what defines the time step. And if we look at the erosion deposition for this now, we should see that there's, yes, it is very different from what we had before. We only had 10 metres cubed a second. We've got some channels starting to cut around the back here, and also across this cut-off here, okay, where the channel cuts across. Okay. So we're just going to leave that running for a little moment now, and pause. Okay, well, we're back again. The model's been running for about another 5 minutes, and you can see it's still running very slowly, and that's because it's doing loads of erosion deposition. Okay. Now, if we look at the erosion deposition, we can see, again, yes, it's doing more. It's starting to cut across in these places. And we can also look at things such as the flow velocity, which is quite interesting here. I'll get rid of the erosion depositions in the background. And you can see we've got quite high velocities down the channel. Low velocities where water's deep in the pools, for example, here. But where we've got this cut-off, where the river's trying to cut across, we can see we've got very high velocities there. You know, the flow is low, it's trying to reach a lot of discharge across, so we get high velocities. Okay, well, I'll pause the video here and we'll come back to this in a few minutes again and see how it's changed. Okay, back to the model again, and now we've run 0.7 of a minute, which isn't very long, but like I said, there's a lot of erosion deposition going on. And if we pause the model for a second by pressing on the pause button there, we can now have a look at the DEM underneath, because we've had, I think, quite a lot of erosion and deposition that's occurred. And if we can check here, yeah, lots of erosion here on the edges of the channel and deposition in the centre of the channel. And if we're going to have a look at what it actually looks like, we can see that the channel's widened here, it's widened there, lots of deposition. We've had channels cut across the floodplain here, and it's also cut across, it's created a cut-off across here. Now, part of the reason that this is happening, or it's eroding so easily, is because the floodplain is all sand and gravel, effectively. Okay. So it's very easy for the river to just cut across everything. Okay, well, that's very simple to how Caesar operates in reach mode. I suggest what you want to do is if you want to add your own DEM, is to look at the worksheet that describes how to prepare the DEM and explains the key parameters that are involved in it.